Hello, here's your screencast for 6.5 to 6.7. The first section today is on energy of phase changes. So the learning objective is explain changes in the heat, Q, absorbed or released by a system undergoing a phase transition based on the amount of the substance in moles and the molar enthalpy of the phase transition. Okay, so essentially what that means is you want to understand what's happening with phase changes in terms of energy. So over here, this is a heating and cooling curve, and you can see the different states of matter. Down here you have solids, here you have liquids, and here you have gases. And on these flattened parts, that's where the phase changes are taking place. So at the lower temperature, that's where that would be the melting point, and that's where you have the phase changes of melting and freezing that take place, depending on which direction you're going. If heat is being added, that means you're melting. If heat is being removed from the system, that means freezing is taking place. And same thing up here. At this point, you have the boiling point. That's where vaporization and condensation takes place. Then you want to understand, in terms of the phase changes, which ones are absorbing energy and which ones are releasing energy. So absorbing energy, that's going to be an endothermic process. They're also called cooling processes, and that's going to be melting and vaporization. The system has to absorb energy to make those phase changes happen. So again, energy absorbed, that's melting and vaporization. For energy being released, and that's an exothermic process, and that's considered a warming process. That would be going right to left on this chart. So that would be condensing and freezing. So condensing and freezing are considered exothermic, or processes where energy is being released. Another concept you want to know, when a phase change is taking place, heat energy is being released or absorbed, but the temperature remains constant. And the energy that's being absorbed or released just goes into the structure of the particles and how they're changing their behavior and their movement. But during a phase change, the temperature will remain constant. The next section, 6.6, is on Introduction to Enthalpy of Reaction. The learning objective is calculate the heat, Q, absorbed or released by a system undergoing a chemical reaction in relationship to the amount of the reacting substance in moles and the molar enthalpy of reaction. And the essential knowledge for this section is really just working with delta H, and this is really our first look at delta H. Delta H is the change in enthalpy for a system. And really what that means is it's referring to heat flow. So when you see delta H, it's talking about heat flow, as in how much and which direction. Delta H, the units for that are generally in kilojoules per mole. And I put this over here. This is just to show you what all the different things mean. But when you see delta, you're probably aware of that. That means a change in something. And H is the enthalpy. It's heat flow, heat energy. Sometimes you see a superscript 0 right there. That means you're under standard conditions. That's not a real big deal, but standard conditions are 298 Kelvin. Any solutions would be 1 molar, 1 atmosphere of pressure. So that's what that superscript 0 means. And then a subscript right here, we'll just talk about the type of process that's taking place. It could be vaporization, combustion, but there's lots of different types of delta H, and the different types of processes that take place they're denoted by that subscript right there. But if you see delta H, it's talking about heat flow. Then the other thing you want to know is, what does a positive and negative delta H mean? Positive means that heat is flowing into the system, so that means it's going to be an endothermic process. And negative means that heat is flowing out of the system, so that's going to be an exothermic process. And the last section, for today is 6.7 on bond enthalpies, and the learning objective is calculate the enthalpy change of a reaction based on the average bond energies of bonds broken and formed in the reaction. And the essential knowledge for this section is really working with this equation right here. This is just another way that we find delta H for some type of reaction. It's where we take bonds broken minus bonds formed. So this is really referring to reactants minus products. Because in a chemical reaction, for the reaction to happen, we have to break the bonds of the reactants and new bonds have to be formed to make the new products. And when you break bonds for the reactants, that means we're adding energy. To break bonds, you have to add energy to the system. So it's energy absorbed. And when bonds are formed, energy is going to be released. Sorry, bad writing, but hope you get the idea. Energy is released to the surroundings. So to break bonds, you add energy, and when new bonds are formed, that energy is released, and we're breaking the bonds of the reactants, and we're making new bonds for the products. So with this setup right here, these would be our reactants on the left side, and this would be our product. So the bonds that need to be broken are, first of all, there's that carbon-carbon triple bond. So then you would just make a list over here. You have one of these carbon-carbon triple bonds, and then you have two of these carbon to hydrogen single bonds. And then in the H2 right here, there's two of these hydrogen molecules. So there's two of these hydrogen-hydrogen single bonds that all need to be broken for this reaction to happen. And then you're given a table of bond enthalpies or bond energies, and these would be numbers that would be given to you on any test. They're not anything that needs to be memorized. So then you can look up numbers for these, multiply by the number of bonds of each type, and add all those together. And then the bonds that are formed, you look at your product and you look at the structure and see, well, what bonds are forming. So there's one of these carbon-carbon single bonds. So you have one of those. And then it's surrounded by hydrogen. So there's 6 of these carbon-hydrogen bonds. And then just like the reactants, you can look on a table, figure out the bond energy for each one of these, add all those together. And then you get a number here, a number there, just subtract them to get the overall delta H for this reaction. And that's how you work with bond enthalpies. So it's always broken minus formed, reactants minus products. Right, and that is all for today. Have a great day.